This video is an incredibly important video. What I'm going to outline in this video is what I use to address a vast majority of right-angled trigonometry situations. Consider this triangle that I have created here. The side of length y is called the opposite side to our angle A, which I also have labeled as theta. Right? So y is opposite because it's straight across. And then the side of length x is called the adjacent side to angle A because it's right next to it. So previously we defined sine to be y over r. And we're still going to use those same definitions. We're just going to put different words to it, different thoughts to it. Instead of y over r, I'm going to think of it as the opposite side of the triangle divided by the hypotenuse of the triangle. And for cosine of angle A, I'm going to think of it as the adjacent side divided by the hypotenuse. Now, you can certainly think of it as x over r, but as we progress through this right-angled trig, we're not always going to be on the Cartesian plane. Sometimes our triangle's just floating, and it's a lot easier to think of it as opposite side and adjacent side. Tangent of our angle A is our opposite side over our adjacent side. And then we know that the other three trig functions are just the reciprocal. So we have a little mnemonic device to help us remember the main three. We say the SOHCAHTOA. Quickly, SOHCAHTOA. And that just helps us remember that sine is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side divided by the hypotenuse. And tangent is equal to the opposite side divided by the adjacent side. Seriously, I use SOHCAHTOA like all the time with right-angled trig. That's my first thing. Pythagorean theorem, then SOHCAHTOA. So let's find all 6 trigonometric values for both angle A and angle B. Now we'll need all 3 sides of our triangle to list out our 6 trig functions. So let's start by finding our hypotenuse side. Pythagorean theorem tells us our hypotenuse squared is equal to 7 squared plus 24 squared. That's 49 plus 576, 625, and then we'll take the square root. And get h to be 25. Notice that's the exact same thing as r equals the square root of x squared plus y squared. It's the exact same thing. We're just thinking of it slightly differently. All right, so this side is 25. And we've got 2 sets of trig functions to find. One when A is our angle, and again when B is our angle. All right, so let's start with A being our angle. And when we do this, we're going to be using this opposite adjacent hypotenuse thought process rather than x, y, and r. Sine is equal to our opposite side divided by our hypotenuse. Here, maybe I'll do this. Opposite over hypotenuse. So that'll be 7 over 25. Cosine of angle A is going to be the adjacent side divided by the hypotenuse. That's 24 over 25. And then tangent of angle A, that's our opposite side over our adjacent side. That'll be 7 over 24. The other three trig functions will just be the reciprocal. So cosecant of A will be 25 over 7. Secant of A, 25 over 24. And then cotangent of angle A will be 24 over 7. Let's do it again, this time with angle B as our angle. So you'll notice that since we've switched our angle, the opposite side changes. Now 24 is our opposite side and 7 is our adjacent side. So sine of angle B, our opposite over our hypotenuse, will be 24 over 25. Cosine of angle B is adjacent over hypotenuse. Adjacent side is now 7. Tangent of angle B, that's our opposite side divided by our adjacent side. That'll be 24 over 7. And then the other three will be our reciprocals. Cosecant of angle B will be 25 over 24. Secant of angle B, 25 over 7. And cotangent of angle B, it's going to be 7 over 24. Let's try another example. But really, I mean, it's no different. It's all the same definitions. We're just thinking of it kind of more generically, like, oh, the opposite side or the adjacent side. So when we're not on the Cartesian plane, we can use the same thought because it applies to the Cartesian plane as well. I like to know fewer things, but know how to apply them more frequently. And especially in trigonometry, there's a lot of things to know, a lot of little things. So if we can really master some of these main concepts, then we don't have to memorize all those little things because we can extend these main concepts to those other things. This time they didn't draw the picture for us. They're telling us that we have a triangle ABC where C is a right angle and sine of A is equal to 4/7. So let's draw this and label this. And if you would have labeled it slightly differently, like switched A and B, that's no big deal. Your answers will end up being the same, even if your diagram's labeled different. Because, you know, the opposite and the adjacent side are going to change. Alright, so sine of angle A is equal to 4/7, and sine is opposite over hypotenuse. So this will be 4 and this will be 7. We'll do Pythagorean theorem to find our missing side. I'll call it little b because it's across from angle B. 7 squared is going to be equal to 4 squared plus b squared. 49 is 16 plus b squared. So 33 is equal to b squared. Square root of both sides, we get b to be the square root of 33. And that does not simplify. these in different colors so they pop. You can see them easier. Now that we have our completed triangle, let's find the 6 trig functions for angle A and then for angle B. So let's start with angle A. Sine of angle A. Now, right, this will be our opposite side for angle A. Opposite over hypotenuse, they gave that to us. 4/7. Cosine of angle A, that's going to be our adjacent side divided by the hypotenuse. Square root of 33/7. And tangent of angle A, that's our opposite side divided by our adjacent side. It'll be 4 over the square root of 33. And we'll rationalize that. We get 4 square root of 33 over 33. And then we'll have our reciprocals. Cosecant of angle A. Seven over 4. Secant of angle A. It's going to be 7 over the square root of 33, which we'll rationalize. We'll get 7 square root of 33 over 33. And then lastly, cotangent of angle A. Now, tangent we already rationalized, so remember when you do the reciprocal, you want to grab what you had before you rationalized and do the reciprocal of that. That way you won't have to rationalize another time here. We get the square root of 33 over 4. Next, we want to find our 6 trig functions, this time for angle B. So our opposite side changes. Now our opposite side is the square root of 33, and our adjacent side is 4. Cosine of angle, let's start with sine. Sine of angle B is going to be our opposite side. Square root of 33 over our hypotenuse. Cosine of angle B, that's our adjacent side divided by our hypotenuse. That'll be 4/7. And then tangent of angle B, that's our opposite side divided by our adjacent side. Opposite is square root of 33. Adjacent side is 4. And then we'll do our reciprocals. Cosecant of angle B, that'll be 7 over the square root of 33, which we'll rationalize. That's 7 square root of 33 over 33. Secant of angle B, it'll be 7 over 4. And then cotangent of angle B, our reciprocal, 4 over square root of 33, which we'll rationalize. We get 4 square root of 33 over 33. SOHCAHTOA. It's just an extension of our original trig definitions. Now, something I want to point out is notice with our answers that sine of angle A is equal to cosine of angle B, and tangent of angle A, that's the same as cotangent of angle B. Secant of angle A is going to be the same as cosecant of angle B. Now, you probably thought all that cos stuff had to do with something. Sine, cosine, secant, cosecant, tangent, cotangent. And it does. Those pairings, those are called cofunctions. And we'll discuss cofunctions more in a future video. But it is a fact that with cofunctions, sine of angle A and cosine of angle B, they're going to be equal to each other.